Hello guys, today we are going to talk about what is slope, what does it mean, and how we can find slope from a situation, table, tile pattern, and graph. So first let's talk about what even is slope. There's a couple different things that we can hear what slope is dependent on the context in which we are talking about. So slope can be a rate of change. So for example, if we're talking about the speed of a car, we're going to talk in terms of miles per hour. Or a lot of times in the grocery store, you'll see price per pound. We can take steps per minute, climb a distance over a given time. So that's kind of an idea of what slope is. It's a rate of change of something. On a graph, we see that this rate of change is the ratio between the vertical and horizontal distance between the 2 points. In other words, it's how steep the line is. And it also tells us the direction of the line. Is the line increasing? Is it going up? Or is it decreasing and going down? And we can also talk about slope as a growth rate. So how fast or slow is something growing? So all of this kind of encapsulates the definition of slope and what it means to be a slope, and how really steep something is, or how fast something's growing, or the rate of change at which something is happening at. So first, let's talk about slope from a situation. We have 4 different types of situations here, just so we can look at how slope is portrayed in the real world. So for our first problem, we have Kathy can run 6 miles in 1 hour. So we're really asking, how fast can she run in an hour? And the answer is 6 miles per hour. So we say 6, and then typically we have seen this MPH, which stands for miles per hour. And really what we're looking at is we're looking at the ratio of 6 miles for every 1 hour. And that is her slope. This means that 6 would be the slope in this case. All right, now Dan can run 16 miles in 2 hours. So we have, in this case, 16 miles for every 2 hours. We have this nice ratio. And if you noticed, 16 and 2, we can simplify. So we can simplify 16 over 2. 2 goes into both of them, so we can divide by 2, and we get 8 miles for every 1 hour. Oh, no, without the S on there. For every 1 hour. And 8 divided by 1 is going to be 8. So Dan can run 8 miles per hour. So in this problem, 8 is going to be Dan's slope. That is his growth. That's how fast he can go. All right, Susie now, we have can bike 6 meters in 2 seconds. So we write our distance over time. So we have 6 meters for every 2 seconds. If we can reduce this, we want to. So 6 divided by 2, 2 can go into both of those. So 6 divided by 2 is 3. So we have 3 meters for every 1 second. And this means that Susie can bike 3 meters per second. So 3 in this case is going to be representative of our slope. All right, finally, Joey spent $20 on 5 pounds of apples. So in this case, we aren't doing a distance over time. This one's going to be dollars over weight. So we have $20 over 5 pounds, or lbs, of apples. We can try to reduce this. We see that 5 can go into both 20 and 5, so 20 divided by 5 is going to be 4. We have $4 per 1 pound of apples. So our slope in this case is 4 divided by 1, which is 4. So we have 4 for our price per pound. So we can write that out, price per pound. And in this case, 4 is going to be representative of our slope here. So we're really just trying to figure out how many miles in 1 hour, or meters in 1 second, or dollars per 1 pound. And that is going to be our growth. That's going to be our slope. And if we can, we're going to try to simplify that as much as possible in order to find our slope. So this means, for example, I can say Kathy can run 6 miles in 1 hour, but if I double both of those, she can ride 12 miles in 2 hours. And I can continue to increase my rates, but the nice thing is with simplifying the fractions, I will always get the same slope. So that's kind of the nice thing with slopes from different situations. No matter how large the numbers are, we can always reduce that to the same exact value. All right. Now, if we're looking at a table, we don't necessarily have miles and hours and meters and seconds and dollars and pounds, but we do have changes in our x variables and changes in our y variables. So if we look at our very first table here, we can know that each step going in our x direction, we are adding 1 to the value. So we're going up just by 1. So we can think of this as going up every hour. Our y values, in this case, we want to see what they are growing by each time. And in this case, to get from 3 to 5, we are growing by 2. To get 5 to 7, we are growing by 2. 7 to 9, growing by 2. And 9 to 11, we are growing by 2. So each time, we are growing by 2 units. And so for our first table, our slope is going to equal 2. Now that number might change if our x values were not going up by 1, but we will wait until level 2's video to get into that discussion about how that slope might change. All right, for this second table, once again, we want to figure out how we are growing. So we look at our x variables, and we notice that each time we're growing up by 1. All right, so that's very nice. We know that's very consistent. We have a nice growth of 1 in the x direction. And so once again, we can kind of think of that as our dependent variable. It's the, my apologies, the independent variable. It is the hours, the seconds, the stuff that we cannot control necessarily. And y is going to be our changing variable. It's going to depend on our x variable. And so we can see that y in this case from 12 to 9 actually decreases by 3 each time. And so in the case for this table, because the change in our y value is decreasing by 3, for every value of x that we increase by, our slope is going to equal -3. So our change in our variables is that we are decreasing by 3 every single time. So that's going to be our slope value. It's what we're either increasing or decreasing by every time. So that's how we can tell slope from a table. Now, slope from a tile pattern. Once again, we're looking at how much we increase or decrease by every time. What is the growth of this pattern? So if I look from the first shape to the second shape, I notice that I have 1, 2 additional tiles that I did not have before. And if I look at my third block, I have 1, 2 additional tiles that I did not have on my second set of blocks. And finally, if I look at my fourth set of blocks, I have 1, 2 additional tiles that I did not have on my third set of blocks. So each time my figure is growing by an additional 2 tiles, therefore my slope for this tile pattern is going to equal 2. All right, finally, we want to look at a graph. We want to see how we are growing or showing our slope, showing our steepness of these lines in the graph. So if we look at our very first graph on the left, we always want to note that we read graphs just like we read books, from left to right. So if we scan the left side of the graph and look all the way to the right, we see that our graph is increasing, which means we're going to have a positive slope value. So now what we need to do is we need to look at how do we go from one coordinate point, let's take this one right here, to the next coordinate point. Let's take this one here. And we can see if we count up, we have gone 1, 2, 3 spaces up. So our slope for this graph is going to be a positive 3 because we are increasing each time by 3 units. All right, let's look at our final graph. This one didn't have nice coordinate points, but we can look at where our line crosses an x and y value perfectly. These are called lattice points. So we see we have one here, and we want to look right over, if we stepped one place over, where that next section would cross. So we have the coordinate points 0, 2, and 1, 0 here. All right, once again, we want to look, how do we get from one point to the very, very next point? And in this case, we are actually going down 2 units. So because we are going down 2 units, our slope for this guy is going to equal -2. So our slope is going to tell us how do we get from one point to the very, very next point. And these are just basic examples of nice and easy tables and tile patterns and graphs that we can look at to identify a slope where we are just increasing or decreasing by a nice easy amount. It's very easy to see on the graph. We're looking how we get from one coordinate point to the very next coordinate point on the x-axis. So next level, we are going to see a few more challenging problems as the slope starts to get a little more complex.